let's move on to the next chapter, which is lines and triangles. So, we see a lot of geometric figures in our day-to-day life, right? So, when you look at an object, it's made up of different geometrical shapes. You could see rectangles, squares, circles, triangles, lines. Very obviously, lines. Lines are everywhere. Even for constituting a very simple shape, you need to put in lines, different types of lines, right? So let's see what are the properties of these lines, triangles, and the shapes we see around. And first, let's start with lines. So before getting into lines, we need to know that what are points. A point is a fundamental concept that represents a specific location in space. It is often described as having no size, shape, or dimensions. Think of it as a dot on a piece of paper or a pinpoint on a map. So what is a point? What comes to your mind when you hear the word point? Basically, this comes to your mind when we talk about points, right? So what is this? This thing, if we put it somewhere, that is a point. I'm saying that there is a map, right? There's a map here, and we are saying there is a point here. So that point represents the particular location. But if we put a point anywhere, right? If we put a dot anywhere, that is a point. So points, just as simple as it is, it have its own beauty. How is it? Because we could draw anything out of a point. Like this point could be the center of a circle, right? This point could be the origin of a line, right? This point could be anything. So the explanation of a point is very vast, right? So here it is said that it's often described as having no size, shape, or dimensions. So we can't put any dimensions to this point, right? If I'm saying that a particle is starting from one point and moving across this place with a velocity something, this point would be the initial velocity point, right? So if the same time I'm saying that if this point, and this is the distance which it is covered, it starts from this point would be the origin of the distance, right? So a point is actually the fundamental concept that represents a specific location in space. So wherever you put a point, there origins a particular set of things, right? Now let's move on to the next concept. Now, definitions related to lines and angles. So we have different things called lines, angles, and what if it combines together and what do we get, right? Everybody knows what is a line. If we draw something like this, it's a line, right? We see it everywhere. If we see a rectangle, we could see there are 4 lines here, right? So everything is constituted upon lines, whether straight lines or curved lines, right? Curved lines are called something else, but here let's talk about straight lines. So first about what is line segment. A line segment is a part of a line that constitutes of 2 endpoints and all the points in between them. It is a straight path that starts at one point and ends at another point. The 2 endpoints mark the limits of the line segment. So what is a line segment? If we are talking about a line, if I draw this much and say that it extends up to 2 different, in 2 ways it can extend, right? So I could say that this extends onto both sides. I'm taking a line and I'm saying that it extends up to both sides, right? Now, what if I'm taking a segment of line in here? So this is our line here, right? So this segment or this piece of line is called a line segment. And how do we define line segment? The line segment have a defined point where it starts, like here, and then there is a defined point where it ends, right? So a line segment is a line with initial starting point and ending point. And the whole points, if we are taking a line, what does it constitute? If we zoom into a line, what is here? So a line would be a connection of points which are very, 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 very close to each other. That is, I'm taking, again zooming in here, we could see points lying very close to each other, right? So that is what is happening in a line. So we are taking a collection of points, like there is one point here, I'm placing the next point here, and then there is some points in between these two, right? When we are connecting all the points, we'll get a form of a line. That is a line. So when we are talking about line segment, it is a collection of points in between the starting point and the ending point, right? Now, let's move on to a ray. So what is a ray? Let's see. There's a very dark night going on, right? Right, it's a very dark place and you actually light a torch, right? You're actually lighting a torch, and what do you see? We could see the beam of light going from this torch. We have a torch here. We have a torch here and we are lighting it, and we could see the lines going like this, right? So the light propagates like this, right? So it starts from one point and we don't know where it ends. It just goes on until there is an obstruction, right? So it starts from one point and it just goes on infinitely, right? Now that is called a ray. So a ray is a part of line that starts at a specific point and goes on forever in one direction. So is it turning the direction and going this side when we are lighting a torch? No, right? It just goes on in one direction. Imagine you're standing at a particular spot and shining a flashlight in front of you. The light from the flashlight travels in a straight line and continues indefinitely, right? So it just starts from this point and it goes on to another point, not another point, it just goes on, right? That straight path of light is very similar to ray in geometry. So in geometry, we are saying that if we have one point and the line is going towards any direction, it is called a ray. So from the same point, we could produce infinite amount of rays. How come? We could draw a ray in this direction, this direction, this direction, this direction. Anywhere we could get a ray. So if I take another point, then too we'll have different number, like a lot of rays from one point, right? It could be in any direction too, right? But one direction it is. That is, if we are starting from one point and it is moving towards one direction, it never changes the direction. It just goes on in that direction. So that is known as the ray. Here we could find an example where there is a screen and there is a camera and there is a lamp, right? So what is happening? The light from the camera is passing through the screen to the object and the object is illuminated by the lamp, right? So here we'll get an image, right? So again, the whole traveling of light is in the concept of ray. We always talk about the ray of light. What does it mean? The ray is a type of line which have a starting point, but there is no ending point, right? Now, let's talk about lines right now, different types of lines, right? So let's talk about intersecting lines. So what is this term give an image to you? So when we hear a name, like when we hear cats, dogs, we just get the image of cats and dogs in our head, right? So what is this image? What is the image you get when you hear about intersecting lines? So intersecting lines are lines which intersect each other, that is, they cross over each other, right? Lines are straight paths that go on forever in both directions. When I talked about lines, not about line segments, line segment we have a starting point and an ending point. Lines just go on in both directions, right? When two lines come together or cross each other at a specific point, we say that they intersect. So what does intersecting means? So I have a line here, I'm taking another line and placing it on top of it. So we have a point where the two lines meet, right? These type of lines are called the intersecting lines. Think of it like two roads crossing each other at a junction. Let's say we have a road here, right? To go from here to here and here to here. Now we have another road here. We'll go from here and here. What is this place? This place is the junction, right? This junction is similar to what is intersecting lines. There are two lines and they're intersecting each other, right? Now what is intersection point? When two lines intersect, they meet at a single point. This point is called the intersection point. It is the exact spot where the lines cross each other. In this case, our intersection point is here. Why? That is the point where they intersect each other or where they meet each other, right? Or they cross each other. Now, angles at intersection. When lines intersect, they create angles at the intersection point. These angles can be different sizes, shapes, depending on how the lines meet. For example, if the lines cross each other over a 90-degree angle, it's a right angle. So what is it? Here, we see that these lines are intersecting at a point. And what is the angle between these two lines at intersection? This is 90 degree, right? Again, here it's 90 degree, here it's 90 degree, and here it's 90 degree. Let's say that we have a line like this, and we are taking another line which goes like this, right? Now, here the angle of intersection is less than 90, right? Here the angle of intersection is greater than 90, right? So this is the concept of angles at intersection. Now, infinite solutions. Two lines can intersect at one point, and this is the most common scenario, right? However, there are cases where two lines may never intersect. These lines are parallel and always remain at the same distance from each other. So, we have two lines, right? In the other situation, two lines are moving on like this, right? So, there is a distance between them, which means that it will keep on going with the same distance with each other, right? So, that means that they're never intersecting, right? Other than that, other than the case of parallel lines, if we have a line like this and we have another line like, little bit more here, like this, at one point it's gonna intersect, right? And that one point, right? Mostly two lines would have one intersecting points if the line is not parallel line. Now, concurrent lines. What are concurrent lines? Lines are considered concurrent when they intersect or meet at a common point. So, concurrent lines are the lines that cross or touch each other at a single point. This point of intersection is called point of concurrency. Now, we were talking about two lines, right? What if we have more than one line, two lines like here? So, we have one line going from here to here. It may go and extend to the two directions. Now, we take another line and we see that they're meeting at one point, right? We take another line and this line is also meeting them at the same point. Now, this point is called the point of concurrency. So, what is concurrent lines? So, when different lines, multiple lines meet or touch at a single point, these lines are called concurrent lines. Now, let's talk about parallel lines. We already told that, if there are two lines which is moving at a distance, like see there is a distance here, right? There's a distance. So it just extends to both the directions and it just moves on, and there is a particular amount of distance in between them, right? There is always a particular amount of distance in between them. They're never meeting. They're never going like this and coming towards each other and meeting, right? So these lines where they have a particular distance apart from each other, and no matter how far they extend, they're not meeting, these type of lines is called parallel lines. So these are a few properties of parallel lines. First of all, distance. Parallel lines are always the same distance apart. You can think of them as two lines that maintain equal gap between them, like train tracks. So have you seen like train tracks, like there is two tracks, like there is two lines, right? Two rails, and there is a distance between them. What if they meet? Can a train travel through them? No, right? So this is called, this particular lines which have like two rails, right, called the distance. They never meet. Parallel lines never intersect or cross each other. They go on forever in the same direction and never touch, even if you extend them infinitely, right? Visual representation. When you look at parallel lines, they will always appear to be running side by side without converging. If you draw two straight lines on a piece of paper, they don't touch. No matter how long you extend them, they are parallel. So if I'm taking a piece of paper and drawing two lines, right? This line is crooked, but consider it as a straight line. So if I'm extending this line, is it going to meet this line? No, it's not. It just goes on forever, right? These types of lines is called as parallel lines. Now, symbol. In geometry, we use a symbol to represent parallel lines. It looks like two vertical lines with an arrow pointing in the same direction. When you see the symbol, this symbol, see, parallel lines, the symbol is this. It indicates the lines are parallel. So if we are saying that this is line A and this is line B, how do we say that A is parallel to B? We just write A is parallel to B, right? So these are a few properties of parallel lines. Now let's talk about angles. What are angles? We see angles everywhere, right? So if I'm taking this this marker and I'm just the stylus and I'm just holding like this, if I'm taking a line, imaginary line, there is a line going from here to here, and I'm picking the marker and the stylus in this direction, the angle is something which is formed between the intersection point, right? There is an intersection point here between the imaginary line and this stylus. So there would be this imaginary line is going from here to form an angle here. So how do we measure how much did it go from here to here? We measure it with using angles. So in mathematics, an angle is a way to measure the amount of turn or rotation between two lines or rays that share a common endpoint. Just like I said, I have a stylus here and I have a pen here. So these are in the same direction, like 0 degree we call it. And now this pen is going on and rotating, right? This is how we rotate. Now the amount of rotation is measured using angle. Now I could say that it's a 90-degree angle because it is like straight, right? It's perpendicular to this, right? Now, when it's like this, we could say that it forms a straight line and it's 180-degree angle, right? So, this is the concept of angles. So, what is the one thing we have to think about? For any angle to form, we need a common point of two lines emerging. We have a point here, and one line is emerging from here and another line is emerging from here. This have an angle. Let's call it theta or x or anything, right? So if I'm taking another line from this point, again we form an angle with both these lines. From this line also there is an angle between them, and from this line also there is an angle between them, right? Now I'm saying that there is a line. I'm drawing another line from the same vertex. Is there an angle between them? Yeah, there are more than one angle between them. Here is one angle and this is another angle called x, right? So, angles are used to describe the direction or orientation of objects, right? And the measures is in degrees. We just used 90 degrees, 10 degrees, 20 degrees, right? It's measured in degrees. To visualize an angle, imagine drawing two lines that intersect at a point. Let's say we have two lines intersecting at a point, right? The point of intersection is the vertex of the angle. This point of intersection is the vertex of the angle. The two lines extending from the vertex are called the arms or side of the angle. So this is the vertex and this is the arms or sides of the angle. And we have an angle here, we have another angle here, we have another angle here, and we have another angle here. We have four angles there, right? Yeah. So this is about angles, and let's study about the classification of angles right now. So let's talk about acute angles. What are acute angles? So firstly, let's consider a circle and let's consider two lines across each other for them. So what is this angle? This angle is 360 degrees. So one total rotation is completed. We say that 360 degrees is covered. So what is this? What is this much angle? That would be 360 divided by 4, right? So this becomes 90. So this is a 90-degree angle. So 90-degree angle is called a right angle. So we have four 90-degree angles if we divide the circle equally into four parts, right? So an angle is called an acute angle if it's lesser than 90 degrees. See, this angle, if it's 90 degree, I could say that this angle, this distance, right? This is lesser than 90. This is an acute angle. Any situation it goes. If I'm taking an angle like this, the angle between these two lines is again less than 90 degree because it's an acute angle. An acute angle is a type of angle that is less than 90 degrees. To understand this, let's imagine a full circle. A full circle is made up of 360 degrees. Now if we divide the circle into four equal parts, each part will be 90 degrees. An acute angle is any angle that is smaller than 90 degrees but greater than 0 degrees. So what if I say that the angle is 0 degrees? That is, I have a line here and I have another line which is just on top of here. That means I have the stylus here and I have the pen here. If it's like this across each other, this is 0 degrees of rotation, right? It haven't rotated yet. Once it starts rotating, I could say that, the angle is increasing between them. It have a common vertex and the angle goes increasing. And once it reach here, it is a 90-degree angle. So any angle which is less than 90 degree and greater than 0 degree is called as acute angle. Now, what is an obtuse angle? In geometry, an obtuse angle refers to an angle that is more than 90 degrees but less than 180 degrees. To understand this, let's imagine a pizza slice. When you cut the pizza into two equal halves, each half makes a 90-degree angle at the center. That's a right angle. So, let's avoid this. Now, what is obtuse angle? We just talked about how a line is here and we have another line from here. This would be 90 degrees, right? Now we know that this angle is greater than 90 degree, right? This type of angle is called obtuse angle. Even here, we could say it's 90 degree when it's perpendicular to each other. What is perpendicular? It means that there is a line which is intercrossing this line, but in a straight way, right? There's a straight line here and I'm intercrossing a straight line. Then it becomes a 90-degree angle. It's called a right angle. And we say that this line and this line is perpendicular to each other. Now here, if we are drawing a right angle, this is one line, the right angle would be somewhere around here, right? So the right angle would be somewhere around here. When it's greater than 90 degrees, we call those angle obtuse angle. Even see here, we have a beautiful picture here. If we say that, let's see, we could see here, it's a right angle in a spider's web, right? So if we are moving a little bit here, greater than 90 degree, these type of angles is called obtuse angles. Now let's talk about right angle. We already talked about right angle, but still, a right angle is a special type of angle that you often encounter in geometry. It's an angle that measures exactly 90 degrees. How do we come up with this 90 degrees? I told you, right? There is a circle, we divide it into 4 parts, and at the point of intersection, if it's rotating 90 degrees, it becomes perpendicular to each other. We get an L shape, right? For an L, here it is 90 degrees. Here also we could see a table here. And what is the angle between these two edges? Let's see the angle between these two edges. This would be 90 degrees. Again, this would be 90 degrees. It makes to the floor a 90 degree. Again, it makes a 90 degree here, right? So, this is very much used in geometry. So, this angle which is 90 degree is called as right angle. Now, what is a straight angle? An angle formed when two rays or line segments share a common endpoint, right? So, a straight angle is particularly a type of angle that is formed by a straight line. It is a very special angle because it exactly measures 180 degrees. So we talked about the situation where there was this stylus and a pen, right? So it goes on, it makes 90 degrees. Now it's a right angle. Now it moves, it increases, it becomes an obtuse angle. And then at one point, the end points of this coincide each other. And it's moving in exactly opposite directions in a straight line. So it becomes a straight line from here, right? Here, what is the angle in between of them? That is 180 degrees. How did we get the 180 degrees? If again we are taking the circle, the same circle we were talking about, we had a circle. So we were dividing it into 4 parts, right? The whole is 360 degrees. This is 90 degrees. So it becomes a straight line here, right? This is a straight line, right? This is 90 plus this amount of 90, it's 180 degrees. So we say it's a straight angle if the angle between two lines is 180 degree, right? Now, reflex angle. Angles are measured of how much something turns or opens up. A reflex angle is a type of angle that is greater than 180 degree but less than 360 degree. So, let's talk about the circle, the same example, right? We had a circle here, we divided it into 4 parts. Here we had 90 degrees and here we had 180 degrees and we had 360 degrees as total. So if we have a line here, right, this is the angle from the original position, right? So this angle is greater than 180 degree but less than 360 degree, right? These types of angle is called reflex angle. So let's see with the same pen and stylus example. So here this becomes acute angle which is less than 90 degree. Then here it goes perpendicular to each other. Then it becomes 90 degree which is a right angle. Then it becomes an obtuse angle with the same point of intersection but it's greater than 90 degree. it becomes a straight line here, which becomes a straight angle, which is 180 degree. And now if we go here, what happens? The angle increases from here to here. So this is called a reflex angle, right? So here we see that this was the starting line or a line segment, and it started and it rotated till here, right? This rotation until here, it's an acute angle. This is an acute angle. If we go here, it's a right angle, right? If we are going here, it becomes an obtuse angle, and if we are going a straight line, it becomes a straight angle, and if we move forward with this, it becomes a reflex angle. Now, this symbol is called alpha. Alpha is a Greek alphabet of, it's a Greek alphabet. We denote angle with different alphabets like alpha, beta is another Greek alphabet, theta is there, right? We could just simply call it X or Y or anything. It's your wish to name it. Now, let's talk about bisector of an angle. An angle is formed when two lines or rays meet at a point. Now, the bisector of an angle is a special line that divides the angle into two equal parts. So, here we see a triangle, right? So, we have an angle here. What is this angle? We represent angle by using this. So, this is angle BAC, right? So, we have a value of angle BAC here. Let's say it's x degrees, right? In any variable. Let's say it's like what? This would be around 45 and then greater than 45. Let's say it's around like 60 degrees or something, right? We can't, it's not an, okay, we'll talk about triangles later, but let's say this is around like, 75 degrees angle, right? So, we are actually drawing a line from the point where the angle is starting, where the line is starting, where the angle is formed. We are drawing a line from that point, okay? Here we draw a line, and this intersect the angle in such a way that each angle here, let's say this is y degrees, this would be also y degrees. Why? We are bisecting the line. That means we are dividing the angle into two parts. So this y would be equal to x by 2 degrees, and this y would also be equal to x by 2 degrees. How come? We are dividing the angle x into two different parts by, so we had an angle here, right? So from here, we are just saying that we have a bisector of that angle which goes from here to here, right? It just divides the whole angle. This bisector divides the whole angle into two equal parts, right? This is known as the bisector of an angle. Now, complementary angle. So, complementary angle is a special type of angle relationship. When two angles are complementary, it means that the sum of their measures equal to 90 degrees. So, let's talk about this complementary angles in a very thorough way. Let's say that here there are two angles. This is a right angle, right? This is 90 degrees. So, if we are saying rather than a bisector, this is 90 degree, rather than a bisector, I am drawing a line on any way. We could draw a line here, we could draw a line from same vertex to here or anywhere, right? So, this angle plus all these angles would be equal to 90 degree, right? So, we could say that this angle is the complementary angle of these angles, or we could say that this angle is the complementary angles of these angles, right? So, what is happening here? The sum of two angles is becoming equal to 90 degree. That is, we add 30 degree and 60 degree, we get 90 degree. Again, we have 50 degree here. What would be the complementary angle of 50 degrees? It would be 40 degrees. How come? We have 50 degrees here. We add some angle to it, we get 90 degrees. So, this means the added angle is 40 degrees, right? So, they complement each other, right? This is a very special case where it's a triangle, it's a right angle triangles, and we have 90 degrees here. When we talk about triangles further, we'll get deep into this, okay? Now, supplementary angle. We just told about complementary angles where the sum of two angles is 90 degrees. Now, let's talk about what are supplementary angles. Supplementary angles are the angles who have the sum as 180 degrees. So, we have an line here, right? And we have a line drawn as here, a ray, right? So, the sum of this angle and the sum of this angle would be 180 degrees because it's a straight line, right? So, these are called supplementary angles. Let's say we have an angle of 80 degrees. What is the supplementary angle of this supplementary angle of this would be 180 minus 80, which is equal to 100 degrees, right? So they supplement each other to form a straight line. These kind of angles are called supplementary angles. Now, adjacent angle. An adjacent angle refers to two angles that shares a common vertex and a common side. To understand this concept better, let's imagine a corner of the room. See yourself standing in the corner of the room and imagine two walls extending from that corner. Now, if you were to draw a line on each wall starting from the corner, you would have two angles formed, right? We have this angles formed going towards this direction. We have another angle going from this direction. The angles you just formed are called adjacent angles. They are adjacent because they share the same vertex and the same side, right? The important thing to remember is that adjacent angles always have a common vertex and a common side. So we are talking about this situation where we have a wall. We have a wall here and it goes on this direction and this direction. This is the corner of a room, right? So we have a side here which is common and which is a common point here. There is one side going like here and another side going like here. So here they form an angle, here they form an angle, right? So these are called adjacent angles. These angles are called an adjacent angle because it have a common vertex, right? It's a common vertex and we have a common side. So I think the concept of adjacent angles are clear. Now, linear pair. Linear pair refers to a special type of angle relationship. It involves two adjacent angles that share a common side whose non-common sides forms a straight line. In other words, when you have two angles side by side and the sum of their measures is 180 degrees. So what is a linear pair? A linear pair refers to a special type of angle relationship. It involves two different adjacent angles that share a common side and whose non-common sides form a straight line. So this is the common side, right? So think that there is something going inside like this. So this shares this forms a straight line, right? So we are taking the same example. Corner of the room, we have a common wall here. We have one side of the wall going there and another side going here. Now let's say that if this line had another thing behind it going like this. So this is the common side and here we have an angle of 180 degrees, right? So this pair, when there's a common side and the non-common side forms 180 degree angles with each other, they're called a linear pair. Now let's talk about vertically opposite angles. So when two lines intersect, they form four angles at the intersection point. Vertically opposite angles are a pair of angles that are directly across from each other and share the same vertex, the point where the lines intersect. So now when we were talking about intersection points, we chose this example, right? So here we can see that there are four angles here, 90, 90, 90 and 90, right? In case of this line. But here we have two different lines, right? And it forms four angles. This is angle A, this is angle B, this is angle C and this is angle D. So what are vertically opposite angles? A and C are vertically opposite angles, right? And D and B are vertically opposite angles. And there's a very interesting property about this, that A and C would be equal and D and B would be equal. How come? Because let's take a line like this and let's take another line like this, right? So when we are saying that they're crossing each other, right? The way they cross each other, the amount of distance they have would be equal to the amount of distance they have over here. So that's how we say that A and C angles would be equal. And at the same time, when we're considering the angles here and the angle here, this would also be equal. We are naming it B and D. So here A and C are equal and D and B are equal. So that is one very interesting property about vertically opposite angles. Now, angle made by a transversal on parallel lines. Let's say there is a set of parallel lines, right? So it goes like this. This never meet, right? Now, angle made by a transversal on a parallel line. So what is a transversal line? If this is a parallel line, we have a line like this called the transversal line. When a transversal line crosses the parallel lines, it creates several angles. Even right here, we could see how many angles can you spot on here? We have 1, 2, 3, 4, 5, 6, 7, 8, right? We have 8 set of angles here. Let's focus on the angles that are formed on the transversal on the parallel lines. So there are 3 important types of angle that we can find, right? So one is corresponding angles. So we are saying that these two lines are similar to each other, right? These two lines are very similar to each other. The only difference is they have a particular distance between them. That is the property of parallel lines. Now we have a line intersecting them and they form angles like this, right? We have A, B, C, D and we have E, F, G, H here. Equality of corresponding angles. We'll talk about this later, but we could see different angles forming here. We have corresponding angles, we have alternating angles, then we have co-interior or co-exterior angles, right? We have co-interior angles, also we also have co-exterior angles, right? So let's dig a little bit deep into this and see what are corresponding angles, alternate interior angles, alternate exterior angles. So we have corresponding angles. These are pairs of angles that are in same relative position on the transversal side and the parallel lines. In other words, if you start at one of the parallel lines and follow the transversal, then the corresponding angle is the one you reach on the other parallel side. Corresponding angles are equal in measure, which means that they have the same angle size. So when we were talking about corresponding angles, let's see, we had a line here, right? See, we have two lines which are parallel. No, okay. Then we have an angle, right? So the angle which is made here would be equal to the angle which is made here. Let's make this line a little bit more, right? So we have two lines and we have an intersecting line, right? So the intersecting lines intersect this line at here and this line at here. So the angle formed here would be equal to the angle which is here, right? Now this angle, it's denoted by another color. This angle would be equal to this angle, right? Now again, this angle would be equal to this angle, right? Now also we have the next angle which is here, which is equal to the angle which is here, right? These are called corresponding angles. Now let's talk about alternate interior angles. What are alternate interior angles? Those angles are located on opposite side of the transversal and between the parallel lines. They are called interior because they are inside of two parallel lines. Alternate interior angles are also equal in measure. So here we could see there are two alternate angles. This is alternate interior angles, right? Because these are inside of each other, and here also these are alternate angles. So now we are saying about alternate interior angle, we say that we have two parallel lines, right? And we have an intersecting line here. Now what are alternate interior angles? So if we are saying that, so we have an angle here, right? This angle would be equal to the angle which is formed here. How is it possible? Because this and this, see, this forms a Z over here, right? So this angle would be equal to this angle. So what is the other interior angle which is alternate? Let's see. So let's say that this angle would be equal to this angle and this angle are a pair, and this angle and this angle are a pair. How come? Again, we form a Z, right? Just like we formed a Z here, and one interior, one exterior, and one interior goes to another exterior. So let's see. There are two cases explained here. One is 130 degrees here and the other is 130 degree here, and here it forms 70 degrees and here also it forms 70 degrees. These are called alternate angles. Now let's talk about alternate exterior angles. These angles are located on the opposite side of the transversal. So on the opposite side of the transversal, but outside the two parallel lines. That is this angle. We're talking about this angle, and they're called exterior because they're exterior outside the parallel lines. They're exterior or outside the parallel lines. Just like the alternate interior angles, alternate exterior angles are also the same. So here we talked about interior angles, which forms a Z. Now these are co-interior angles here and here. This have a different property, but let's keep it there. Now these are exterior angles. This angle right here, let's take a different color to denote them. Okay, so we have one angle here, right? And what is the corresponding angle which is same to here? We have an angle here, right? These are called the alternate exterior angle, right? Now, properties of parallel lines. We just talked about the properties of parallel lines. They never meet, right? The parallel lines always stay at a distance. They never intercross each other. Equal interior angles. When a transversal line, a line that intersects two parallel lines, crosses the parallel lines, the angles formed on the inside between the parallel lines are called interior angles. So, what are interior angles? So, this is one parallel line, the next line which is parallel to it. We have a line crossing it, right? So, these four are the interior angles. So, these are the interior angles, right? And what are the exterior angles here? Let's say these are the exterior angles, right? So, equal interior angles. This and this is equal, this and this are equal, and this and this are equal. So, we are saying that this line, this angle and this angle are equal, right? And this angle and this angle are equal. That means that equal interior angles are formed. Equal exterior angles are also formed. This and this angles are equal, and this angles are also equal. So these are two different properties of parallel lines. Now corresponding angles. When a transversal line crosses two parallel lines, the angles that occupy the same position on two parallel lines are called corresponding angles. That means if we are saying that these are two parallel lines and we are saying that there is a transversal line which crosses each other, we are saying, what is the corresponding angle of this angle? It would be here. Why? This is a parallel line and there is a line which is transversal to it. This angle is formed when the line goes here and there's a transversal line, it's here, it intercrosses. This angle and this angle are equal. So this and this are corresponding angles in this case. And now when we are talking about the other corresponding angle, this angle and this angle would be the other corresponding angle, right? This and this would be the next corresponding angle, and this would be the other corresponding angle, right? Now alternate angles. Alternate angles are formed when a transversal line crosses two parallel lines. These angles are located on the opposite sides of the transversal and on different parallel lines. So, let's draw a new figure to explain what is alternate angles here. So, we have two parallel lines, let's say here, two lines which are parallel, right? Now, we have a line intersecting them, right? Now, the angles which are located on the opposite sides of the transversal line and on parallel lines, right? Now let's see. We have a line, an angle here, right? And these angles are located on the opposite sides of the transversal line on the different parallel line. This angle and this angle, right? They are alternate angles. And this angle is an alternate angle of this one. Now, this angle is the alternate angle of this one. How come? Because it's inside and this is outside. Alternate means alternated. So this and this and this. Here this angle is alternate angle of this one and this angle is the alternate angle of this one, right? Now, let's talk about triangles. We just talked about lines in this session, right? So we have different types of lines. We talked about points in this. So we have points, we talked about angles, we talked about what is an acute angle, what is an obtuse angle, right angle and a straight angle. Then we talked about reflex angle. What are these things? When there are two lines which is having a common intersection point and then this is 0, and then it is an acute angle, it becomes 90 degree right angle, obtuse angle, it becomes a straight angle, and it goes to a reflex angle, right? Now after this we talked about bisector of an angle, that is a line which divides an angle into two different parts. Now complementary angles are the angles whose sum is up to 90 degrees. Now supplementary angles are the angles whose sum is 180 degrees. Now adjacent angle are the angles which have a common side, and they have like different angles going on. Now we call it a linear pair when the opposite sides they have like 180 degree angle difference, right? Then we talked about vertically opposite angles. Then we talked about angles made transversal on a parallel line. We have corresponding angles, we have alternate angles, and we have interior angles, co-interior angles. Now we talked about what all are these, and then we talked about the properties of parallel line, that are they never meet, they have equal interior angle, they have equal exterior angle, the corresponding angles are equal, and also the alternate angles are equal, right?